Unit 5, right triangles. Lesson 5.3, SOH CAH TOA, solving for sides. Don't forget date, time, location that you're watching this video, as well as a parent or guardian sign off. Our right triangle toolbox currently has 3 tools: Pythagorean Theorem, 45-45-90 table, and 30-60-90 table. So we now know 3 of our 5 tools. You can't just randomly use these tools. You have to have specific circumstances. Pythagorean Theorem you use when you have 2 sides and you need a 3rd side. Pythag. Let's go ahead and do this one together. We write out the Pythagorean Theorem. Let's circle, plug, chug. I know that is the hypo because it is across from the right angle. It's important that you identify the hypo right off the bat. Minus 64, both sides. Square root. The opposite of squaring is square rooting. So have 2 sides, need 3rd side, Pythag. Then, if you have a 45-45-90 triangle, you do 45-45-90, leg, 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 root 2. Leg equals leg, and whatever the hypo is, you times by root 2. So down here, if these 2 angles are equal, these 2 legs are equal. Problem is you don't know either of them, but you do know this. Something times root 2 is 5 root 2. Something times root 2 is 5 root 2. Our something has to be 5. And if one side is 5, the other side is 5. So here's another 45-45-90. I'm going to pause about 10 seconds. I want to see if you can't solve for x and y here by yourself in under 10 seconds. You should have gotten whatever times root 2 is 6. This is 3 root 2. Whatever this is also 3 root 2. That's the 45-45-90, leg, 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 root 2. And we had 30-60-90. It goes like this: 30-60-90, short leg, root 3, short leg times 2. So we quickly identify what the short legs are. Go through and just identify all the short legs. That's across from the 30 degrees. Now, draw your sprouts. Short leg to the long leg is times by root 3. Short leg to the hypo times by 2. Short leg to the long leg times root 3. Short leg to the hypo times by 2. Short leg to the long leg times root 3. Short leg to the hypo times by 2. Always start with your short leg. Let's start with this one at the top. This reads We don't want to go to the long leg because we got 2 blanks. So something times 2 is 20. Something times 2 is 20. You should have gotten 10. And times root 3, this is going to be 10 root 3. This reads like this. There's nothing in the hypo, so something times root 3 is 10 root 3. Something times root 3 is 10 root 3. You have 5 seconds. You should have gotten 10. Times by 2, that makes that 20. Something times root 3 is just root 3. What's your something? Your something here is a big fat 1. 1 times root 3 is root 3. Times by 2, 2. So now we have 3 tools under our belt. 3 tools. This by far is the most powerful tool you are going to use in a right triangle. It is called the acronym SOH CAH TOA. Keywords. This is the introduction to what's commonly called trigonometry. We're doing a basic intro. You're going to be using these 3 concepts, the sine ratio, cosine ratio, tangent ratio. Again, leg and hypotenuse is something you need to be familiar with. We have 3 tools under our belt so far. 3 tools with right triangles. All of these only work with right triangles. They don't work any other circumstance. If you have a right triangle, have 2 sides, need 3rd side, Pythag. If you have a 45, 45, 90 triangle, leg, leg, leg root 2. 30, 60, 90 triangle, short leg root 3, short leg times 2. But it leads us to this question. What if the angles in a right triangle are not special right triangles? In other words, the angle is not 45, 45, 90 or 30, 60, 90. And what if you only have one side? For example, let's draw ourselves a triangle here. Let's say we have an angle here which is 17 degrees. And we have a single side. Let's say this right side right here is 10 inches. And we want to find the length of this side. Now what do? It's not a special right triangle. We can't use Pythagorean Theorem because you need 2 sides. Now what? The answer to this is that to solve for things like this, when you have not a 45, 45, 90 or 30, 60, 90, when you have unusual angles, you're going to be using something called ratios of sine, cosine, and tangent. By the time we're done in the next 30 minutes, you are going to feel so smart because you're going to have fancy vocabulary and everything you're dealing with is decimals. And you're going to become the master of both fancy vocabulary and decimals, and you're just going to feel brilliant in the next 30 minutes. I promise you. But to use these ratios, I need to introduce to you a certain kind of vocabulary. You have to be able to label a right triangle using these terms. Hypotenuse, which you always know, then something called the opposite and the adjacent side. We're going to be using a symbol called theta. This is the Greek letter theta. It is used as a variable for angles. So it's like a 0 with a little thing across it. That's actually a Greek letter. And just like we use x for unknown numbers, in trigonometry we use theta for unknown degree angles. Now watch very carefully. Theta is going to represent an unknown angle that we are working with. So we're going to label opposite, adjacent, and hypo. In this triangle, your hypo is always across from the right angle. So hypo is hypo, that never changes. I'd like you to sweep our theta here. We're angle theta, let's say it's just generic. That's the angle we're working with. Now go across from theta. We're going to label that side the opposite. And right next to theta, but not the hypo, is called the adjacent. Warning, when your theta moves, your opposite and adjacent moves. So here, there's your right angle. That means this is the hypo right there. Sweep theta, your angle. Go across. That makes this the opposite side. Go right next to it. That is the adjacent side. Notice I always start with the hypo. Why? Because that doesn't change. The opposite and adjacent changes depending on the angle we're using. Let me give you a more particular example. So if we were to solve this triangle for our unknown y, the very first thing we have to label the hypotenuse, which would be right here. Our opposite, so we're using this degree angle 32. Sweep it. That would make this x the opposite. And the adjacent side means the side next to the angle we're working with, but not the hypo. That's how you label opposite and adjacent. Super important. You can do this on your own. Sweep the given angle and label the hypotenuse, opposite, and adjacent. Identify x and y as either hypotenuse, the opposite, and the adjacent. Do this on your own. Pause. Welcome back. You should have a red pen in your hand. Taking a look here. This, of course, 24 is our hypo because it is across from the right angle. 54 is our theta angle we're using, so that makes y here the opposite, and that makes x here the adjacent. Coming down here, you start with your hypotenuse. If that is your right angle points to the hypo, so y here is now hypo. Theta is your 21, so that would make 8 your opposite, and x your adjacent. You have to be able to label. We're not doing short leg and long leg. That only works with 30, 60, 90s. This is not 30, 60, 90. It is an unusual angle. And you have unusual angles, meaning not 45, not 30, not 60. You start by labeling opposite, adjacent, and hypo. Now, the ratio of two sides. Remember, ratio is simply a fraction. The ratio of any two sides of a right triangle in reference to a certain angle, which we will call theta. They have certain names. The very specific ratios have specific names. Let me give you a demonstration. In this triangle, I'd like you to sweep angle A. So just sweep angle A. That's going to be our theta. Now let's label opposite, adjacent, and hypo. 3 is going to be our opposite. 4 is going to be our adjacent. And 5 is across the right angle is going to be our hypo. So we're going to work with 3 different ratios. One ratio is when you take the opposite and divide by the hypo. So I'm going to go 3 divided by 5. I'm going to change that to a decimal. So learn to think in terms of money, and it's easier to think of 1/5 rather than 3/5. Let's see, 1/5 of $1 is 20 cents. So 3/5 of $1. Notice I'm taking it out to the 4th decimal place. When you work with these ratios, we take them out to the 4th decimal place. So one ratio you're going to use is opposite over the hypotenuse. Just leave a blank there. We're going to come back to that. Another ratio you're going to use is adjacent over hypotenuse. In this case, our adjacent would be 4. My hypotenuse is 5. We've already figured out 1/5 of $1 is 20 cents. So 4/5 of $1 is 80 cents. So another particular ratio we're going to use is adjacent over hypo. Put a blank there. And the last one we're going to use is opposite over adjacent. So in this case, our opposite is 3. Our adjacent is 4. Think 1/4 of $1 is 25 cents. So 3/4 of $1 is 75 cents. And that is opposite over adjacent. Now, these particular ratios have names. Opposite over hypo. We call that the sine ratio. Adjacent over hypo. We call that the cosine ratio. Opposite over adjacent, we call that the tangent ratio. Sine, cosine, tangent. So the sine ratio is opposite over hypo. The cosine ratio is adjacent over hypo. The tangent ratio is opposite over adjacent. That is where we get the acronym SOH CAH TOA. The sine of an angle theta equals the opposite over hypo. Sine opposite hypo. SOH. We call that SO. The cosine of an angle theta equals adjacent over hypo. Cosine adjacent hypo. CAH. The tangent of an angle theta equals opposite over adjacent. That's where we get TOA. I want you to say this acronym like this. Pay attention. Mimic the way I say it. SOH CAH TOA. Say it again. SOH CAH TOA. Think so like you're proving a point. So, CAH, like a crow, kite. CAH, CAH. Think of someone stepping on your toe and you're in pain. TOA. That's how you're going to remember this acronym. Let's put this together and do the next page. SOH CAH TOA. We're going to find the required ratios given the triangles. Round the ratio to the 4th decimal place. So in this case, we want the cosine of z. Start by sweeping z, and now label. That makes your 21 the opposite. 20 is your adjacent, and the right angle always goes to the hypo. If I want the cosine of the angle z, remember cosine, is adjacent over hypo. It's right there. Cosine is adjacent over hypo. So in this case, our adjacent is going to be 20. Our hypo is 29. Yes, you may use a calculator. Get out your calculators. You're going to go 20 divided by 29. Do that on your own calculator. Make sure you're getting the same thing, and we're going to round to the 4th decimal place. So it's 0.689, and then that's 6, that's a 5, so that becomes 7. 0.6897. So the sine ratio of angle Z in this case is going to be 0.6897. Remember, a ratio is a fraction. A ratio is also a decimal. Make sure you understand those are interchangeable. I'd like you to do this one on your own. Pause the video, restart when you're done. Welcome back. We wanted the tangent ratio of angle A. So we sweep angle A. That means 8 is your opposite. 15 will be your adjacent. And your hypo is always across from the right angle. That will never change. So tangent is TOA, like someone stepped on your toe and you're in pain. So it's opposite, which is 8, over adjacent, which is 15. TOA. So you do 8 divided by 15. 5.333 repeating. And that's in reference to this angle theta. Now there's literally hundreds and hundreds of ratios corresponding to specific angles. You can even have decimal between angles, like 33.3 degrees. But these ratios are standardized. Now, years ago, in working with these ratios, we used to use tables, like you'll see in a moment. These 2 pages you should have done on your own. Let's figure out if you did these correctly. If you didn't do these 2 pages, do them now before I continue the video. See if you can do these on your own. Pause. Welcome back. Okay, we want the sine of angle Z. So that makes 12 our opposite. 35 is our adjacent. 37 is our hypo. Sine is SOH, S-O-H. Our O is 12. Our H in this case is 37. So 12 divided by 37. So our sine ratio, according to angle Z, is going to be 0.3243. That's our sine ratio for that angle. Let's try our cosine ratio here of angle A. So we sweep A. This makes this our opposite. That's our adjacent. Here's our hypo. Cosine is CAH. So our adjacent is 24 over our hypo, which is 40. .6000. So you notice that these angles change with the ratio. Look at that kind of carefully. See, the angles change with the ratio. Now, we used to work with these ratios, these giant tables. And we would actually correspond. For example, if you had 12 degrees, your sine ratio would be this, your cosine ratio, and then your tangent ratio. Luckily for you, all of these sine, cosine, and tangent ratios, you don't have to look them up on a chart anymore, although I can show you how to do that if you like using charts. They are stored in your calculators. I'm going to show you how to use that in just a moment. Here's the pattern we're going to use. Given any right triangle, that's not a special right triangle, you trace the given angle and you label opposite, adjacent, and hypo. To find any side of a right triangle, you ask yourself what you have and what you need to determine what you do. Have, need, do. Say those three words. Have, need, do. Then you're going to create a proportion to solve using the sine, cosine, or tangent ratios. Remember, ratios are just fractions. Proportion is an equation of fractions. So I've got good news for you. Super good news if you just keep this in mind. When I say a proportion, I mean one of these guys. Something over something equals something over something. You recognize this? We spent nearly 3 weeks on it. If you pay really close attention, what we're going to do for the next 10 minutes will look shockingly similar to what you've already done in this class. Keep this chart from your reference booklet right under your nose. Let me just highlight this chart very carefully. This is the standard equation for the sine, cosine, and tangent ratio. Sine of theta, we put it over 1, equals opposite over hypo. That's why it's called SOH. Cosine theta over 1 equals adjacent over hypo, CAH. Tangent of angle theta over 1 equals opposite over adjacent, TOA. Keep that where you can see it as we move on. Step number 1. We're going to solve for our unknown x. We're given this angle 21 degrees. That's going to be our theta. Start by sweeping that and identify that as your opposite. Here would be your adjacent side, and of course, across from the right angle is the hypo. That hypo never changes. It's always pointing, the right angle points to the hypo. Have, need, do. We have the hypo. We need the opposite. We ask ourselves, well, what do we then do? Look at the combination we have. We have an HO combination. Now, it doesn't matter whether it's HO or OH, but you just ask yourself, what goes with O and H? O and H. It's not tangent. Tangent goes with O and A. It's not cosine, that's A and H. It is OH goes with sine. Now, we copy exactly that equation down. Sine of theta over 1 equals opposite over hypo. It will always be opposite over hypo. Always. Now we circle, plug, chug. Watch what we do very carefully. Sine, let's circle theta. Our theta is 21. Watch what I do. Be very careful. Do exactly what I do. Sine of 24 degrees. Put parentheses around that. Super important. Over 1 equals opposite. Our opposite is x. And our hypo is 16. We're going to solve for x. Super important principle. Never, ever touch a calculator. Do not touch your calculator until that x is completely by yourself. At this moment, before we move on, those of you with TI-84 calculators, you need to make sure you're in degree mode. There is a video right before this one that's only about 1.5 minutes long. If you have one of the larger TI-84 calculators, you need to make sure you're in degree mode. If you have a smaller calculator, like the TI-30 or the TA-30XS, they are automatically in degree mode. You don't have to change anything. But if you have a TI-84 or an 83 or an 89, some of you have, you must get it in degree mode first. There's a video prior to this one. Now I'm going to show you how to use your calculator, but first you don't touch a calculator until x is by itself. So let me copy, write down what you had. We had sine of 24 degrees over 1 equals opposite, which is our x, over hypo, which is 16. Cross multiply. And we get, our next line reads, x equals sine of 24 degrees times 16. Now you ask yourself, is x by itself? The answer, yes. Now you can pick up a calculator. There's 2 ways to do this. If you have one of the larger calculators or test right now, physically touch your sine button. If you actually see the word sine, you're going to follow my instructions on this side. If you touch your sine button and you do not see the word sine, you're going to follow my instructions on this side. Now to do on the left, let's do this one first. We're going to do sine of 24. It is super important you understand. It is not the number 24. It is the sine ratio of 24 degrees. So in your calculators, on the left, hit the word sine. Then 24. Then hit the times button. Then hit 16. Enter is going to be your equal sign. I'll show you what you would end up with in just a moment. So again, if you see the word sine, this is the order you go. You hit the sine button first. 24. And that should be in parentheses. You might have to close the parentheses. Use these parentheses. Times, that whole thing, times 16. Make sure you have parentheses around sine of 24. So it's sine of 24 times 16, enter. I'll show you what you're going to get in just a moment. Those of you who don't see sine, what you do is first is this. You're going to go backwards. You go hit 24 first, 24, then you hit the sine button, and you're going to get that decimal right there. Then you hit times, and you do 16, and hit the equal sign. For both of these, let me show you the final answer, what you should be getting. So my computer calculator works like this one on the right. So I'm going to go 24 sine, notice I'm in degree mode, times 16. If you've done this correctly, your final answer is 6.507786, etc., etc., etc. I want you to round to the second decimal place. That's going to be 6.51. Your final answer here is x equals 6.51, which makes sense because it's impossible for you to get an answer bigger than 16. Why? Because the longest side is always your hypo. Make sure you know where this answer comes from. Do not move on until you know how to get 6.51. If you need to, rewind the video a couple minutes and watch that very carefully. Let's try another one. Have, need, do. Sweep the angle 58. That means this is our opposite side. This is our adjacent side. The hypo is always across the 90 degrees. Have, need, do. This time, we have the hypo, and we need the adjacent. I have an HA combo. Now, it doesn't matter whether it's HA or AH. But you go back to your chart and SOH CAH TOA. And you ask yourself, what goes with AH? And the answer is cosine. And it looks just like this. Look on your chart. It should read like this. Cosine of theta over 1 equals adjacent over hypo. It is always in that order. Now let's circle plug chug. Cosine theta. Our theta here is 58 degrees. So we write it like this. Cosine 58 degrees, put parentheses around that whole thing, over 1 equals adjacent, which is x, hypo, which is 11. Do not touch a calculator until your variable is by itself. Let's get the variable by itself first. So in this case, we're going to cross multiply, and we get x equals cosine 58 times 11. Notice I have parentheses around cosine 58. That is a single entity. Okay, to get that in your calculator, now that x is by itself, let's pull that over here. We have our unknown x is going to equal cosine 58 degrees times 11. Now, in your calculators, on the left-hand side, if you can see the word cosine, you go in this order. You hit the word cosine, has parentheses. Then you do 58, close the parentheses, times, then you do 11, and hit the enter sign. I'll show you what the final answer in just a moment is. For those of you with the smaller screen calculators, you're going to go like this first. You're going to go 58 first. You hit 58, then you hit cosine. So 58, the cosine button, and you're going to times by 11 and hit the equal sign. I'll show you what your final answer should be to this. When you do this, make sure you get this as your final answer. My calculator here functions like the one on the right. So cosine, so notice it says cosine 58 times 11 equals, and I get 5.829111, etc. We're going to round to the second decimal place, which is going to be 5.83. So in this circumstance, my x equals approximately 5.83. Let's try another example here. So we start by labeling opposite, adjacent, and hypo. There's 47. That's going to make our 20 our opposite. X is our adjacent. And here is our hypo. Have, need, do. I have the opposite. I need the adjacent. Notice I have an OA combo. It doesn't matter whether that have need is either OA or AO. That doesn't matter. What does matter is what letter goes in front of an OA combo. And the answer is OA. TOA, like someone has stepped on your toe. Now you write down the tangent ratio equation exactly as I write it down. The tangent of angle theta over 1 equals opposite over adjacent. Notice I did not put any numbers in there. You first write only the equation. And that equation is copied from this part of your reference booklet. Right there. Keep that under your nose. That's what we're copying right now. So now we circle, plug, chug. The tangent of our angle, 47 degrees, put parentheses around that, over 1, equals opposite, which is 20, over adjacent, which is x. Do not touch your calculator until x is by itself. Cross multiply. I have tangent of 47 times x equals 20. X is not yet by itself. I have to get rid of tangent 47. Notice it's not 47, it's tangent 47. That's a single unit. That's why we put parentheses around that. So watch. This is what x is going to be. X is going to equal 20 divided by the tangent of 47 degrees. Now x is by itself. This is how you work it on the larger calculator. You start by putting in the 20. So 20. Then you hit the divided by sign. Then you hit tangent. And you do the degrees, 47. Then hit that enter button. On the large screen, in the small screen calculator, you're going to go with this order. Okay, you start by putting in 20. You hit the divided by. Then you do 47, then the tangent button, and finally the equal sign. What you should be getting is what's on the screen. I'll show you here on mine. Play with your calculator until you get exactly what I get. My instructions are going to follow this right-hand calculator. So I go 20 divided by 47 tangent, and I hit the equal sign. Large screen calculators, you do 20 divided by the tangent of 47. Notice it's 18.6503017, etc. You round to the second decimal place. So in this case, x equals the length of our side, 0.65, approximately. Put the little approximate sign. I'm going to do one more with you, and you're going to do one on your own. I know this is longer. Once you're in class, we'll get a kind of a rhythm going. This will become very easy. We use this when you don't have special right triangles. Let's do one more together, and you do that last one on your own. Start by labeling. We sweep our theta 40. So that means this is our opposite side. This is our adjacent side. Hypo is always across from the right angle. Have, need, do. We have our adjacent. We need our hypo. We ask ourselves, what goes with AH? Ka! Ka! So now you write exactly the cosine ratio down. Cosine of theta over 1 equals adjacent over hypo. That is always the order you go, adjacent over hypo for cosine. Circle, plug, chug. Cosine theta. Our theta is 40 degrees. Cosine 40 degrees. Put parentheses around that. Over 1 equals adjacent, which is 19, over hypo, which is our x. Cross multiply. Cosine 40 degrees times x equals 19. Notice x is not yet by itself. Do not touch your calculator until your variable is isolated. You have to divide by cosine 40. Keep parentheses around that because that's a single entity. So the value of x, which in this case is the hypotenuse, is going to be 19 divided by the cosine of 40 degrees. Try that on your calculators. I'll give you about a 30-second lead here, and then I'll do it on my calculator, and we'll see if you got the same answer. 30 seconds. Do this on your own. Okay. On your calculators, this is what you should have gotten. So I have 19 divided by the cosine of 40 degrees. On my calculator, we go 40 cosine. 19 divided by the cosine of 40 degrees equals, you should have gotten 24.8027, etc., rounded to the second decimal place, which is 24.80. So x equals approximately 24.80. Which, if you look at that, the hypo is always the longest side. So your answer has to be longer than 19. Try these three on your own, my friend, on your own. Restart the video when you're done. Okay, welcome back. I'm going to move kind of fast here because you should have already done these. We have, in this case, the hypo side. We need the adjacent side. This is AH, so it's CAH. You should have cosine theta over 1 equals adjacent over hypo. Cosine 18 degrees over 1 equals adjacent, which is our x, over hypo, which is 21. We isolate x. Your x equals 21 times the cosine of 18 degrees. So I'm going to go 18 degrees cosine times 21, and we get approximately, rounding to the second decimal place, 19.97. You should have gotten x equals approximately 19.97. Check for units. No units. We're just going to write the word units so that you're in the habit of accounting for units. This one, we have the opposite. We want the hypo. I have an OH combo. What goes with OH? So it should have looked like this. Sine of theta over 1 equals opposite over hypo. Sine of 50 degrees over 1 equals opposite, which is 16, over our hypo, which is x. You cross multiply, you isolate x, and x equals, be very careful here, you should have 16 divided by sine of 50 degrees. $16 divided by the sine of 50 degrees. You should have gotten here 20.89, rounded to the second decimal place. Your opposite should be approximately 20.89. Whoops, let's keep the color straight. My hypo has always been blue. 9 units, which makes sense because it's the hypo, and hypo is always the longest side. So whatever I got had to be longer than 16. Last one. Let's check this out. Have, need, do. If 34 is our theta, we have the opposite. We need the adjacent. I have an OA combo, OA, TOA. Should look like this. Tangent of theta over 1 equals opposite over adjacent. Tangent of 34 degrees over 1 equals opposite, which is 15, over adjacent, which is x. Cross multiply. Tangent of 34 times x equals 15. Isolate x. Whatever your x is, it's going to equal 15 divided by the tangent of 34 degrees. Because we had to divide by tan of 34 to get x by itself. So 15 divided by the tan of 34 degrees. 15 divided by, my calculator is 34 tan. You should have gotten approximately 22.24. Congratulations, you have officially finished the longest video of the entire school year. You will not see something longer than this the rest of the year. Thank you for sticking with it. You'll get more practice in class. If you're feeling a little foggy with this, do not worry. The fog will lift, I promise, in class.